Hi folks, Tom Affolter here again, and today we're going to continue our lecture on ANSI SQL and discuss aggregate functions. Aggregate functions are an amazing part of SQL. So up to this point we've evaluated data based on individual rows or records. Every time we do a select statement, we're either going to get back 0 rows or we're going to get back an X number of rows, but we look at our data as being rows or records of data. But what we see is what we see, and that's just simply an assessment of the individual records. Of course, we can sort the data if we want. We can selectively pull data out, but we still end up with individual records. So knowing which records match criteria is valuable, but really what we might want to do is to summarize that data. So up to this point, we've been determining data such as the tallest, the heaviest, the earliest birth date by sorting and taking the top one. You'll recall in a past lecture and in class I've told you that we did that for a time being, but actually we don't want to do that long term. And the reason we don't want to do that long term, as we're going to talk about later, is the fact that if we came back and said who's the heaviest baseball player, if you will, we might find that there's 3 players that have exactly the heaviest weight, but top one is just going to pull the first person back. Really what we would like to have is all 3 of them that have that same matching weight pulled back. So we can determine how many records match a select or select where by looking at the number at the bottom right of the Management Studio screen. So for example, I might ask you how many players were born in the state of Washington. You could go back and write a select statement, get the records returned on the screen, and look at the bottom right corner of the screen and see, oh, there were 7 or 8 that were returned. But the problem is that's not going to do you any good as a programmer. You have to pass that value back to the calling program. Your program can't come in and take a look at the right part of your screen to determine how many records are there. So that's what aggregate functions are going to do for us. So again, looking at that select statement, and I talked about this just a moment ago, it looks at records as a whole. And what we want to do is we want to summarize data now. We want to go back in and look at some specific aspects of our data. Things like how much or how many, or what was the least amount in a group or the most amount in a group, or what was the average of a group. And those are what are referred to as aggregate functions. So rather than returning back a whole bunch of records, typically an aggregate function is going to return back one row and it's going to answer whatever the aggregate function is that you're asking for. The average, the minimum, the maximum, those types of things, the count. In fact, here's a slide that talks about the aggregate functions that we're going to take a look at, and those include the average. So we can go back in, for example, and take a look at a particular team of baseball and say, what was the average weight, for example, of the Seattle Mariners in the year 2008? Or we can do count. Now notice that there's 2 different counts here, and we're going to talk about it. Count now, and it's important too, we'll talk about this. These aggregate functions will ignore records that have nulls in them. So if I went back in and said, I want to count the number of first names that exist, we know that there's a lot of first names that are null for those baseball players that played back in the in the mid 1800s. So if I went back in and did a count, it's going to count all the names that come back, and it's going to ignore all the nulls. In fact, most all of these will ignore nulls. The count asterisk is going to just return a count of all rows. It's very similar to the count. We'll see how they're related in a second. But the count star just says, tell me all the rows that match this. And you're not looking at a particular field. It'll make more sense when we look at these in a second. And then we have max. Max says, give me the maximum number, and it's a numeric. You can actually use it for a string too. But it says, give me the maximum value for this particular column. So we could use this to come back and say who has the greatest weight, the maximum weight. Just like we can use the next one down, min, to say who's got the minimum weight. And then if we wanted total particular columns, for example, we have a table out there that does salaries, and I might want to go back in and take a look and say what was the total sum of all the salaries for the Seattle Mariners for 2007 or the Los Angeles Dodgers for 1995. One thing I should note about salaries as I go along, though, is I think it was probably about 1983, 1984 approximately when they started putting salaries in. So we don't have salary information prior to that. So let's continue and take a look at some more of these. So the way that an aggregate function works, and we're going to take a look at a couple of different formats of this, is you have the aggregate function itself, the word average or min, max, or sum, and typically you're going to include an expression inside of the parentheses that come up, and that expression most commonly is going to be a column. Now it could also be multiple columns. For example, I might want to know the value of my inventory, so I could, and if I know how many parts I have and I know the value of each individual part, if I multiply those together, it gives me the value of that individual part. And if I want to know the value of all my parts, then I could use an aggregate function, as we're going to find out. And instead of just passing a single column in, I could say I want the sum of the quantity of the part times the value of the part together, and that would give me the value of my entire inventory, if you will. We'll take a look at a couple examples of that as well. So all of these fall into that category with the exception of the count asterisk. And the count asterisk just simply comes back and gives me a number. I can say, I want to know all the players who've ever played for Seattle. And it would come back and just give me a total count on that. If I want to know how many people had a last name, though, I would put a field in. So the asterisk just says count all records, just like the asterisk stands for the wild card when we're doing a select. The count here just says count all records that match this criteria. Again, we'll take a look at those in just a moment. So let's take a look at the very first one, and that's going to be the average. An average is going to return the average of the field or the results of a formula that exists inside of a group. So you'll notice here on the slide I've got select average age. Now, before I go on, these aggregate functions are formulas. And anytime you have a formula or it sees a formula, it's not going to return back that column name, because it's really not that column name. I don't want it to return back necessarily date of birth. If I'm looking for a specific piece of data, I might want to have, in fact, I most commonly will have it say something else like the average date of birth or something to that effect. But the issue here is that aggregate functions do not have column headers. So you'll find, pardon me, that every time we use an aggregate function, we're going to have to give it a column header, and this is where you'll have to remember it every single time. Because if you don't remember it, and there's actually I see an error on the slide here, if you don't remember it, then the data won't be retrievable, just like a formula that we put in previously in our select statements. So let's take a look at what we've got here again. This top select statement has a mistake in it because that should be a single apostrophe, although that will work. I try to always be consistent with the single apostrophe like we see down below here. So it says select the average age as, and I'm going to call that column average age, from some table called student where the program is perhaps web development. And it's simply going to go back in, and every column that has every program column that has web dev in it, it's going to take that student's age and it's going to average it together for them. We'll take a look at that in a second. This next guy below here averages the salary, and it's going to call it the average supervisor salary here from a table called employee, but we only want those where the type of employee is supervisor. So it kind of goes hand in hand with the column header that we put in here. And this example at the bottom is showing how we could use, as I mentioned earlier, a formula within it. So assuming that we have a table, and this is an order table, and in that order table someone buys items, so they buy 5 items and that individual item costs a certain amount. I want to know what the average sale is of everything. Well, in order to get the value of that sale, I need to take the quantity times the price. Okay, then I'm going to average that among all my records, and that's going to come back and give me the average, and I'm going to call that average order. Let's jump over and take a look at this one. So I have my SQL already open up here, and let's go back in, and we're going to go into let's go into contributions this time. And in contributions, we have table donations. Inside the table donations, you recall we went through this earlier when we looked at the tables. There's a couple columns in here that I'm not sure what they are. I didn't remove them because that's part of the original table. But the ones that are important for us would be the name of the donor, the city that donor's from, the state that donor's from, their zip code, if they gave an occupation, the date that they made their donation, and then the amount that they donated. Okay, so let's go ahead and make sure I select that contributions table. I'm going to open up a new query. And what I'd like to do, first of all, is let's just ask the table generally, what is the average donation made throughout the entire table? So in order to do that, I'm going to say select, and I want to give it average, AVG, okay? And in AVG, I want to know what the average donation amount is. So I'm going to look at my table, and there's my donation amount. So let's do that. And then from table. And the table's going to be here, table donations. Okay. Let's check it. It says the format's good. Let's execute it. Oh, and I got a mistake here. My mistake is I have no column header, so let's make sure I do that. So I think I'm just going to use a shortcut method here. We'll call it donation amount. And I better put average in front of that. So AVG, and again, let's check it and execute it. And notice now that in the entire table, and there's almost 1 million records that exist in this table, $862 is the average donation. And if I want to go a step further and say, okay, what's the average donation from the state of Washington? So I could say where state, I believe that's, yep, state equals Washington. Okay. And so the national or the table donation, I want to say it's national because there's actually some donations made outside the country. So the entire table donation amount averages out to $862. Let's see what Washington. I'm going to put WA here for Washington. Let's execute it. And we're a bit lower than the average amount, $726. Let's go a step further. Let's take a look at Spokane. So the state's Washington and the city is equal to Spokane. And let's execute that. And you can see that it's $706 for the city of Spokane. So the average just basically does that. It returns a single row back to me, a single row, in this case a single column, although we're going to change that in just a second here. And it's a single value. So this is still a table coming back to me. Why? It's a table, even though it's a single column, it's still made up in that table format. Okay, let's jump back over and take a look at a couple more. Next one we're going to take a look at is the count and the count wildcard. So the first thing that we're going to take a look at is count just simply comes back and counts the non-null values in a particular column. So the first example you see below here, it says count L name as employee count from employee. So what that's going to in essence do is it's going to count every non-null last name. Let's go back in and take a look at this one first, and we'll come back and take a look at the count star in a second here. So I'm going to go ahead and delete out the where clause. And what I want to do now is I want to count, because we remember now, if we went back in and we ordered our data, remember there's a whole bunch of names that are null. A whole bunch of names that are null. So for me to go back in there and I want to know how many names are not null, I can simply say count. And let's go back in and I'm going to do the baseball here this time. So let's jump over the baseball table. Okay, and open up players. Pardon me. Okay, so we know that there's going to be null names in there. In fact, watch this. If we do a select star from players, and then we do an order by name last, okay, and we execute it, or excuse me, that should be named first, and execute it, we get the ascending, and what records pop up at the top are going to be those old-time records, those players you'll see over here in their finale game that played in the 1800s, and we didn't capture their first name. So we have last names, but again, we have no first names on it. So when I go back out there and I want to count, I want it to ignore nulls. I just want to know how many records are there for first name. So here's what I'm going to do. Let's take out the order by here. Increase the size of that a little bit. I'm going to do a count. And this time I want to count all the, and before I go on, look at the bottom right hand corner. This is what I was talking about where we're getting our count. So right now, it's bringing back 18,846 records. So I want to count now name first. And I'm going to call that first names. Like that. Okay, let's check it. Now again, look down below, 18,846. When I execute it, it comes back and says 18,807. The difference is, this is how many of those columns were actually filled in with names. And that's it's an important note here. So when we do a count, like count name first, it's counting how many records. It's only looking at those records now that have names filled in. Now if I want to know how many names that are filled in are from the state of Washington, now I can use a where clause. And I can say where state, or let's do birth state. Okay, equals Washington. Right here. Let's execute that. And there's 196 names from the state of Washington. Now, before I go on, here's one of the things I might want to do. If you take a look at the way this is written out, I've got 196 names, but I might have, 30 different Daves or Johns out there. If I wanted to count distinct names only and repeat names only one time, I want to know how many, unique names are out there, then I can actually put the word distinct in front of this. And by doing distinct now, notice there's 196 names. Let's see how many unique names are in that count. 133. So that means the difference between 196 and 133 were common names. So if David was there once, it's not going to count it a second time. And that's what the distinct statement will do for you. Let's take a look now at this other one, the count asterisk. So the count asterisk is simply there to count. It doesn't look at any particular row. It's simply there to count whatever our where clause tells it to do. So in this case, since I don't have a where clause, it's simply going to count all my records. Let's jump back and take a look at this guy in action a little bit here. And I'm going to give the column header the name count here. Now, count is a reserved word. See how it's read here? Before we determine it's not going to work, let's run it and see. It accepted it. So sometimes it depends on how it's being used. It will accept a reserved word from a column name. In this particular case, it did. But notice what it did is it returned back 18,846. That was the same number we returned back a minute ago when we did that select star from players. And we had to look at the bottom right-hand corner. Okay, so this simply counted every record. It didn't care about any nulls out there. It counted every record. And down below here, now I can put a where clause and say I want to know how many records there are, not how many columns are filled in, but how many records there are where the state, and that would be the birth state, equals Washington. So how many records, and it's, again, I could do a very similar thing by taking birth state and putting it inside of this where the asterisk is, right here. It would return the same number back. Let's prove that. Oops. Players. Now let's execute it. Here I get 196. So now let's take this number right here. Let's copy it. Let's put it right here. Boom. And now we're saying, what are the number of birth states that are filled in where the birth state is equal to Washington? It's going to give me the same number back, 196. So two ways of doing similar things. It just depends on what your particular need is at that moment. If you're just simply counting how many records make a particular match and you're not worried about any one individual column, you're looking at all the records as a whole, you can use the count star. But they're similar, and sometimes there's some overlapping use that you can have. And what is the correct way to do it? The correct way to do it is the way that gives you the answer back. And as long as you're getting the right answer back, and you know it's going to work in the future as well, then I'm fine with it, as would most employers. Okay. So column headers are not automatic, as I mentioned before, in aggregate functions, and this is just going to reiterate that. So again, just like when you're doing any other kind of select statement, every column has to have a column header. And in this particular example on the screen, we're counting how many last names are filled in, and we're going to let that be employee count. I could have also done the same thing, by the way, by doing select count star, and I could have had employee count from employee, and I would have had then at that point, I would have had to go back in and put a where in there though to make it do the same thing. And because if I put a star in there, it's going to count all employees. In this case, it might work, but I might want to go back in there and say I also want records that the last name is not null. It won't matter here because I would assume that every record has to have a last name in it. Okay. So it says it's also important to note that per the DNA reference model, which makes easy tier, it comes back and talks about that presentation, business logic, and data tier, that separation of responsibility. Remember we talked earlier in other classes about, most of what we do in technology falls in one or more of these categories. It's either there to present data to the user, it's there to perform business logic, that's actually to do the math or the formulas, or it's there to manage data. And we're working right now at the data tier. The program that you would write, though, that goes out and grabs data would be business logic. That would be the code that you would do to go out, grab the data, bring it back, and then you would then use the presentation tier to format it on the screen to the user. If it was on a website, that might be HTML. So this one basically says, let's go back through it again, it's important to note that per the DNA reference model, which makes the tier independent, a program receiving the data set from a database engine, again, as I mentioned many times, has no clue of that data's origin. So when I go back and I do an aggregate function, I return back a single number. The program that somebody else may have written or I might have written, all it knows is it's received back, in the case that we've been working on so far, just a single column with a single column header on that, and our job is to pull that data out. And that's what we basically asked for in the beginning. We're somewhere on our screen in our application program, we're asking for the count of the number of employees, and we want to post that to the screen or maybe post that in an HTML report someplace. So we're asking for that data. We don't care where it came from. So let's spend a little bit of time and talk about max and min. The max and the min are used to go back out there and to pull out the maximum or minimum numeric value from a particular column we'll take a look at. And I believe it also works with string values as well. So we'll play with that as well. What do I mean by maximum and minimum? Well, it works great with dates as well. So if I want to know the earliest birth date of a player, remember we have null values in there. This min now will ignore the null values and actually give us the minimum date. Earlier, we had to write a select statement that told it if we return it back, first of all, sort the data ascending, smallest to largest, but we also then had to tell it to go back in and ignore nulls. This max and this min statement will automatically ignore the nulls, and it's important to do that because the min would always be a null. And remember, null is not a value, so you would expect min not to pull back a value. So let's take a look at some examples of that. So back into baseball, if we went back into that baseball table that we've had, and let's do a select star from players. Okay, and I look at the date, and let's order by, and I think it's birth date. Let's double check here. So it's birth date. So I want to order by birth date. Okay. And I execute that. And if you look over now at birth dates, where are we at? Right here is our birth date column. You'll see that I have a whole bunch of nulls at the top. And as I scroll way down, and I'm not sure how long this is going to take me, as I scroll down, oops, let's go back up again. I see, by just looking at my data, that the earliest birth date is April 17th, 1820. Okay, so let's take a look at how I would determine that number with a simple min command. And again, I'm looking at birth date. So what I would do is I would do a min here, and the column is birth date, and I'm going to call it earliest B-day from players. And there's no reason to have an order by right now in an aggregate function. You don't need order bys in aggregate functions because you're not sorting, you're getting a single column back. So watch this. So now I've got the column from players. Let's see, it better come back up with this 1820 date. Let's see what happens. And there you go. It gives me back that data. Now previously, I could have gone back in and sorted that data out and pulled that up. So and that single column as well. So how could I have come up with something similar? I could have done this. I'm going to change this in a second here, so I'm just writing it out first. Order by, let's try this again. Order by birth date. Okay, then I would have to have a where clause that would ignore the nulls. So again, remember we did that previously. So I'm going to say where birth date is not null. Okay, and then all I want to have is the birth date column showing, but I want to take the minimum of it. I mean, not the minimum, I'm sorry. I want to take the top one of it. Let's see, I'm going to run both of these simultaneously. So to do that, I can either select none of them, and with both of them unselected, do execute, or I can highlight them both. Or if I want to just run one at a time, I could highlight just that one. So let's run them both. And notice they both come up with that same date here. Much easier to write this guy out, though, than it is this guy right here. But it does give me the earliest birth date. Now, I don't have to worry about ties because I'm asking for the birth date. So if there's 5 people that happen to have the birth date of April 17th, 1820, there's no loss here. This works out just fine. But later, we're going to find out that there may be a problem with that if there's ties. If there's ties down below. This case, I don't care what a tie is. If I came back and said, who are the players with that earliest birth date? Right here, and you did a top one, you just give me the first player. That's not what I'm looking for. Let's look at the max birth date. The max birth date is going to tell me now who is the player now that is the youngest player, at least in this table. Or at least what is the player's birth date that's the youngest. So I'm going to do a max here. So I do a max birth date, and let's change that to latest birth date, and we'll run that guy. So I'm just going to highlight him alone, run it, and we'll see that there's a player now born July 27th of 1995 playing baseball. Okay, and I could do the same thing up here if I chose to, and all I would have to do in this case is flip this order, and now the null doesn't make any difference. This, although it's not going to hurt it, I don't need it there because nulls are not going to sort as the latest date. But again, let's prove that. So I need to make this now descending to sort backwards. And if I run this guy, I get the 1995 again. Same. Both of these statements are going to produce the same thing. Okay. If I didn't put top one in here, though, watch what would happen. I get all the birth dates back, so I have to put that top one in there. Obviously, this is the much better way to do it on the top. Let's see, is there anything else we need to take a look at on the max or min birthdays? Nope. But before we go on, and I might have a slide that talks about this, what I would like to do, though, is show you, so far we've done a couple of different aggregate functions. Watch this. So we did the count. So if I want to know a count, and I want to know the count of how many birth dates there are, and that's date, that's birth date. Okay, so I want to know how many birth dates, and I'm going to call that num b days. Now watch what I can do now. I also want to know what the minimum birth date is. And I might want to know what the max, and I'm going to call that min b day. And I also want to know what the max birth date is. And then I can do a from, and in this case it's players. So you can combine aggregate functions on the same line. It's still going to return one line back to you, a single line of data. Let's check it. It says it's okay. Let's run it. And I've got 18,360 birth dates, and then I have the earliest date, as we did earlier, birth date of April 17th, 1820, the latest of July 27th of 1995, all in the same line. So you can combine multiples, but when your program on the other side receives it, it just receives one row, 3 different columns back in with these column names on the top of it. We can also put where clauses in there. So over here, let's go back to, let's play with this min again because I jumped ahead just slightly. Okay, let's take these guys out. I want to know the earliest birth date for someone born in either the states of Washington or Oregon. So where birth state is equal to Washington, or, and you got to put the complete logic in here for right now. It'd be nice if you could just say or Oregon, but you can't. So you have to put complete logic. Or birth state is equal to Oregon. Okay, let's check it. It says okay. Let's execute it. So the minimum birthday would have been 1868. April 10th of 1868 would have been the earliest birth date from a player from the states of Washington or Oregon. Now remember, if I put end in here, watch my data is going to come back as null. It can't answer the question. There is no date. It's not possible. You cannot have a column that is birth state that has both the state of Washington and the state of Oregon in it. If you had that, it would be WA, maybe OR or ORWA, but it wouldn't be separately Washington or separately Oregon. It just doesn't make sense. It's not possible. So just a little bit of review there. So we got to put it back to an or. It's got to be one or the other to get the data back. Let's take a look now at sum. Sum does exactly what it says. It takes, before I go on, I do want to go back. Let's do a maximum minimum. I want to test one thing out here. What if I want to know the minimum name last? Let's see what happens here. Will it let me do this on a, let's just do this part of it, on a text column? Let's see what happens. It did. So what it does, folks, is it's going to tell me when you sort your data what the minimum or the maximum would be. Look at this. If I come back over here now and I say I want the minimum maximum for the state of Washington, okay, I get Abrams back for the minimum of Washington. If I want to know the opposite side of it, then I'm going to have to do an order by clause. Order by name last, descending. Oops, what did I do wrong here? Oh, I can't do an order by. I apologize. Cannot do an order by. There's nothing to order in here. Don't know what I was even thinking there. So I'm doing the minimum last for the state of Washington. So if I want to know, obviously, if I want to know the other side of it, gosh, don't know what I was thinking, folks. It's max. And the max name, which is going to be the closest to Z down below, is Zasky. And if we want to know from the entire table, it's Zich, Z-Y-C-H. So just to show you that you can use the max or the minimum with text columns as well, or with date columns. So you can use numeric columns, you can use date columns. You do not. I don't believe it would make any sense to do it with a bit column. A bit column is a 1 or a 0, or a true or false. So now let's get back to the sum statement. The sum statement is used to total a numeric column. This is not something we're going to ever use with a character field. So if I want to come back in there and I want to know, let's take a look at what's the entire weight. Let's see here. What do I got? Nah, let's not do baseball. Let's come back down and deal with contributions here. So let's flip to contributions. Let's get rid of this. Flip to contributions. Just like that. Okay. And now what I want to do is this is going to do some pretty cool stuff. I want to select the sum of the donation amount of the entire table. Okay. Total donations. We'll call it total donations. And that's from table donations. So it's going to sum, again, the entire table up and tell me, out of those million records out there, how much money was donated entirely. Okay, I'm not sure if I can read that number. So let's see here. It looks to be 7,970,000,000. Nope. Here's what I'm going to do. I'm going to copy that number. I'm going to paste it up here. And so notice what I did here, folks. I went down to that column. I copied. I could copy with the header too if I wanted. And by the way, as long as I'm going at that, you could take this table, copy it into Excel, and it does a pretty good job of formatting it. And you could take output here if you were creating a report format and let Excel do the pretty stuff if you had to. Okay, so I'm just going to go back in here and put my commas in and see what we're looking at. $797,066,056 in this entire table donated. So now let's go back in and play around with it. I want to know how many donations were made for the state of California. So where, and this is just state, equals CA. And there we go. Whoa! Again, that looks to be a number I can't read. It's too small. Is that 10 million? No. Oh, doggone it. Got to do this again. There we go. So there's that. $102,043,559 from the state of California. Now, if I want to know, I know how much was donated from California. Let's take a look and just continue on. What about the average from California? Okay, so I will call it the average donation. And then I'd like to know what the maximum donation was at the same time. What was the maximum donation amount? And this is real data, folks, although I need to update it a bit because I think it's about 6 years old, 4 years old. Okay, and I'm going to say, I'll just call that the max. So only from the state of California. This is some pretty cool stuff. Watch this. So we decided the total amount. The average donation made for the state of California was $907, and the largest amount donated was $246,500 in a donation. Let's look in the state of Washington, how that worked out. State of Washington. Okay, state of Washington was, looks like $14,460,969. The average donation amount was $726, and the largest donation amount was $138,058. Let's try just Spokane. So in this entire table, $788,724 were donated. The average donation amount was $706. And the largest donation, notice that's the same as the state of Washington, was $138,058. So Spokane, whoever donated this, and we're going to take a look at that later, whoever made that amount was from Spokane, and that's also the largest in the state of Washington. And then if I wanted to know in a particular zip code, where zip equals, let's try 99207 and see. Okay, execute it. So in the zip code 99207, there was $9,710 donated. The average donation was $334, and the largest donation, individual donation made, was $1,000. So I live in Colbert. Let's try what Colbert is, 99005. And again, 14,000, that's a little tiny community, Colbert, $14,905 donated. The average donation was $648, but the largest donation made was $2,000. Pretty impressive what you can pull out with these aggregate functions. And again, it just comes back to you in a single data set. This is what's referred to as a data set. And of course, we can go back in the sums. We can add nulls into it as well. I should note too that a lot of people will confuse sum and count together. If I say, how many people did this, that's a count. But if I said, how much was donated, then we're dealing with a sum. And I know I catch myself playing around with those as well. So you always want to play around a little bit. And also notice that sum works also, as I mentioned earlier, with formulas. So in this bottom example you have on a screen here, I'm summing the unit price column to the quantity column, and I'm doing that for all my orders for just one customer, whoever that customer 1298 is in this orders table. So we talked about combining the aggregate functions before. I said we can put multiples. In fact, we just did that just a moment ago where we put multiple aggregate functions within the same column. It's important to note, though, that all those aggregate functions you put in the same row are going to be dealing with the same data. In this case, all of them will deal with all those records where the department is warehouse. They all will derive from the same data. So we're counting all the records from the same data. We're going to get an average income from that same data. We're going to get the minimum age from that same data, or the max data from that same. Okay. Now, I want to go in and show you a trick and a tip here. And this is a power user. This is one of those things I talked about earlier in the class that you're not going to see in a book. And we'll take a look at this. In the past, I told you that when you do a select top one from employees and you order by income, that you're going to get the income amount, but you're not going to get the employees with the top income. You're just going to get the top one on that. And that's going to be an issue for us. So one of the things I want to point out here is how we can solve this in two steps. And this is going to require you to it's not hard, it's very simple, but it can look complicated. So I want you to bear with me here, and I'm going to walk through this in baby steps. So what I'd like to do now is, let's go back and take a look at some of the things that we were looking at before. I want to know the player within, let's go back into baseball. Okay, so I really want to know what the player is that has the heaviest weight, the player. Now, let's take a look at how we've been doing it in the past. So what I did in the past, what I had you do in the past is select top one, and in this case we'll do name last, comma, jumped into caps, name last, comma, name first. Okay, and let's put we'll do the largest weight, and then I'm going to do from players. Okay, and then I want it to be sorted by weight, so then I'm going to do an order by, and we're going to order by weight. Okay, and I want the heaviest player, so I'm going to order by weight descending. And if I execute this, boom, I get Walter Young at 320 pounds. Okay, now that's going to be fine, and it just happens to work out this way that Walter Young is the only player that has a weight of 320 pounds. But what if there was 2 or 3 different players that had that same weight of 320 pounds, and I'm asking for the player or players that had the greatest weight? This isn't going to work, and in fact, we're going to probably not want to use this at all. But let's go through the process of figuring out who that player is or who the players might be. Okay, so I'm going to get rid of this code right here, and the first thing I want to do is figure out, I want to get back this 320 pounds here. So I want to do a select the maximum weight, right, from players. And I'm going to call that, I'll just call it for now, again, I'm just going to refer to it as weight again. So I execute that, I should get back the 320 pounds. Okay, now, if I was to go back into my select statement and do a select star from players where weight is equal to, and I just simply plug that 320 in, 320 pounds, it's now going to give me back that Walter Young or all the players that match. In this case, it's just going to be one player. It's going to give me back Walter Young here. Okay, so again, what happened was, how I did this is I ran that statement first, boom. It gave me the 320. Okay, then I went back to my table and I said, give me the player or players that have a weight of 320 pounds. And when I did that, it gave me back that Walter Young record. Okay, now had there been more than one player, let's try this. I'm not sure. Let's try height. Let's change this to height. Because I want to try to find one where I get more than one back, more than one record that matches. So the maximum height from all players, let's see what that is. Okay, that's 83 inches. So now I'm going to come back over here and I'm going to say height is equal to 83. And when I run that, it comes back and gives me a single person. So let's work on this a little bit more. See if I can come up with one. Let's do where birth state is equal to Washington. Okay, and let's run that one, and I get 81, and let's do an 81 here, but I have to put the where clause here to match. So I have to do weight and birth state equals Washington. Let's see if I can come up, oops, not 2 wheres in there. Let's see if I can come up with 2 records. It's not going to work for me in this particular case. Let me think here a little bit about how I might do it. Okay, here's a good one I just thought of. So we have a debut date. That's the date that the player played their very first game. So this is one that's going to work out. I want to know the earliest debut date, the minimum debut date here. Okay, so let's take this out. And I happen to know I'm going to get more than one record because you can't have one player play the very first game. There had to be 18 players playing the very first game. How do I know that? Because you have an offense and a defense in baseball, and it takes at least 9 players on a team. So there had to be at least 18 players that will have played in the very first game. So this should tell me the very, very first game that was ever played that's recorded in Major League Baseball. So let's see what it tells me. So the very first game that was ever played was played on May 4th of 1871. Okay, the first one on record. Now, if I want to know all the players that played then, I could do this. I could say select. Now, let's do it the way we did it before. If I did a top one here, and I'm going to do all records from players where the debut date is equal to, and we decided that was May 4th, so 5/4/1871. Okay, so let's take a look. It's going to give me one record back. because this is the way I'm just simulating what we did before. So it's going to come back and say, hey, there was this fella by the name of Art Allison who played in that very, very first game. Well, the problem is top one just gave me the very first name, but it didn't give me all the names of the players that played in that very first game. So I need to take top one out. Watch this. So if I take top one out here, okay, it's now going to come back in here, and it's going to give me 18 different names. I'm surprised there was only 18, because you would think they would have, extra players playing, but it looks like they had 9 and 9 in the very first game that was played. Okay, so there's the 18 players that played. So notice the way I got this data to come back, okay, was number one, I went back in and I wrote a statement that gives me back the minimum date. And I determined that the minimum date when we ran that was May 4th of 1871. That's the data right here. So then I went back and said, okay, I want all the players that played on that debut date, so I just plugged it into a select statement, just like this. And when I plugged it into that select statement, it came back in and gave me all the players. But I had to do that in 2 separate steps. Now, what I'm going to show you now, folks, is how we can do that in 1 step. Okay. Now, first of all, that statement right there, that number, was derived entirely from that statement, was it not? Sure it was. Okay, where I got that right there was this guy right here. So now, if I take this statement out entirely, because notice that's what it returned back. If I take the statement out entirely, and I'm going to put parentheses in there right now as a holder, okay, as a holder, then I'm going to take this entire select statement that we have up here, I'm going to copy it, and I'm going to paste it right there. Now, what's going to happen, folks, the order of calculation, the way it works is, this statement is going to run first because it's inside parentheses. This is the order of calculation in almost any programming language you deal with. The parentheses are going to be dealt with, the inner parentheses first. Okay, and this is an aggregate function, so that doesn't mean the same thing. We're talking about the order, the parentheses that surround the entire statement here. So that statement will be run by itself, and it's going to return back that date. So when I run this entire statement together, check this out. 1 statement, instead of having to have 2 of them, which is very difficult when you write a program to have it come back in 2. Your ultimate goal is to write it, all your data, so 1 statement returns everything back you need. Check this out. Right there, it returned back all those 18 players. It figured out the minimum date, and then it applied that to this select statement on the other end. So let's try a different way. Let's do a... let me get rid of a couple things here. Let's take a look at the minimum birth date. Or excuse me, let's do the minimum height as we have here. So let's do height. Okay. Now we know that it's going to bring back that fellow that played that we've looked at before, the little guy that was about 3.5 feet tall. Okay, so if I run that right here, that statement is going to give me back the 43 inches for his height. Now I want to know who that person was, so I can come down here and I do select star, or whatever column names you want, from players, where, and this case, I want to do where the height in that column is equal to what we just looked up, 43. Now, if there were more than 1 player, but there's not, but if there were more than 1 player that were 43 inches, this statement would bring it up. But there's only 1. Okay, and it brings up Eddie Goodell right here. Okay, now what I want to do is I want that to be a single statement. So since this guy right here was derived from that entire statement, I can get rid of that 43 and replace it with parentheses. Then what I do is I grab this entire statement right here, okay, and I will, in this case, I'll cut it, Control X, and I'll paste it right in the middle, right there. Boom. Okay, now I'm going to go ahead and run that statement. And now I get the Eddie Goodell back. It's pretty cool how that works, folks. It's very, very, very powerful. And again, you're not going to see this inside book. So any place that you have a number in a formula, then you can replace that with a select statement. We're going to take a look at that a little bit more in depth as time goes on. But let's go back to this contributions table now, because a minute ago we looked up that record, and we want to find out in that contributions table, who was it that made that donation in the state of Washington that was the largest donation? So I'm going to go ahead and wipe all this stuff out. jump back over to my contributions table here. Okay, and let's open that back up so we're looking at the contributions. Okay, and I want to know, well, let's rewrite that statement we did before. So I want to know what the maximum donation was, donation underscore amount, from table is table donations, okay, where, and we decided that it was, excuse me, we decided that it was the same donation amount in the state of Washington, so let's do that, where state is equal to Washington. Okay, now I'm going to give it a column header here, so I'm going to call it max. Let's execute that. So I run it, and here is that $138,058. So now I could figure out who that person was by doing a select statement. Select all records from table donations. Okay, and I want to do where state equals Washington, because I have to have the same where clause. Where state equals Washington, and the donation amount is equal to the amount that we have on the screen, $1,038 and $138,058. So 138,058. That's pretty small print in here. Okay, now let's find out who that person was. So execute that. And it tells me that it was Don Barbieri in Spokane, and he made that donation in 2003. Now, let me tell you that that was the year that Don Barbieri ran for, he ran against, I think it was George Nethercutt back in that day, for U.S. representative to Spokane, the Spokane region. And that's where that came from. So now let's go back and make this, because right now we had to do that in two statements. We had to figure out the donation amount, then we took that donation amount that we have right here, and we plugged it in right here. But if I take where that came from, what derived that amount, and I replace it with parentheses, and I come back here and I grab that entire statement, I copy it, and I paste it right in here. Boom, paste it. Just like that. Now I execute just that statement, I get the Barbieri coming back. So it's extremely, extremely powerful, folks, and we're going to see there's a lot of different places that this is going to be a benefit. This is why I'm going to tell you from this point forward, do not use top. Now, it's not to say that there's not a place for top, but the fact is this is a cleaner, more precise way to do it. This gives you exactly, if there's any duplicates, this will give you back those duplicates, whereas top will not. You're specifically telling it you want 1 from the top or 5 or 10, but not the 11th that might match the 10th. Okay, so this slide just goes through and talks a little bit about how we did what we just did a moment ago, how we put the parentheses in there, and that worked just fine. Let me go back in and I want to do one other thing here. Check this out. If I take a look and I want to know, let's go back up to baseball here. And this is a little bit more complicated than the one we did before, but it should make sense if you watch it carefully. What I want to do now is I want to know what the average weight is for a player from Washington, born in Washington. So I'm going to do the average weight, and I'll call it weight. I'll call it AVG weight. Average weight from and players where's my, keep doing that, where birth state is equal to Washington. So the average weight of a player, okay, let's see, oops, select average weight. Oh, I still got contribution selected. I thought I'd change that. Let's come back up here. You probably noticed that. Okay, now it's selected. Let's rerun it. So the average player born in the state of Washington right now is 193 pounds. But what I'd like to know is, how does every player now in the state of Washington relate to that as a percentage or as a decimal. So for example, I would like to know, I want to select let's do name last, name first, okay, and then I want to know the weight, okay, but I want to take that weight now and, well, let's just write it out long first, okay, oops, from players where, no, my enter key is not working here. Try that again. Where birth state is equal to Washington. Just to make sure. So first of all, just to make sure that statement's going to work. It did. Now what I'd like to know is I want to know how this relates to the average weight of a player. So what I could do is something like this. I could say take the weight and divide it by the average weight. Okay, and we looked up, let's see what the average weight was. We ran the average weight and it was 193 pounds. So I put 193 in here. Okay, now the issue we have, folks, is we played with this. This is an integer field, right? Isn't it? Let's look at weight. Weight is an integer divided by an integer. So let's run this and see how this is going to look. Notice I end up with these zeros and I didn't put a column header in here either. So let's do AVG, and I'm going to put a plus minus on it. Will it let me do that? AVG plus minus, it will not. So I'm going to put apostrophes around it so it lets me get away with that. Okay. Now the problem is I have to introduce a decimal to this. So I'm going to do a 0.0 over here, and if I run that, boom, it now comes back and it tells me how these particular players compared. So if the average weight was, what was it, 100, and let's go back and take a look here, rerun that again. The average weight's 193. That now tells me that George Abrams, who was born in the state of Washington, was 170. He was 88% the average weight. Or we've got this Jamie Allen, who's 205 pounds. He was 106%. Now again, remember, these are decimals. They're not percentages. We don't care. It's not our job to format these as percentages. Our job is to deliver this back to the person that asks for the data, and then that person will then, in the programming language, format it for percentages. So our job is just to bring it back as a decimal right now, and it's working great. But the problem is now for this to work, we have to run two different statements. We have to run that statement first, and then we have to plug that 193 in and put that 0.0 in here. But really what I want to do now is I want to have that number, this number right here, generated from that statement. So it's just like it was before. Even though it's not in a where clause, it's in the select list, I can do the same thing. I can tell it, go out there and on your own calculate that. I'm going to grab that entire statement, copy it, and paste it right in here. Just like that. Just like that. Okay. Now, if I come back in and I execute this guy, well, it's working, except now I'm back to where I was before, because now I've got this 0 or 1 because it's integer and integer. So I have to introduce one side of this formula, I have to introduce to one side of this formula a decimal. And what I can't do is put a 0.0 in here. So this is where you have to do that multiply times 0.1. What I could do is I could take this entire statement right here and multiply it times 0.1. And let's just see if it'll let me do it on the outside of it right here. So I could do times 0.1. This is not going to work. And the reason is excuse me, not times 0.1, times 1.0. The reason is I really need to introduce it to the answer. See, if I did the times 1.0 here, it would do weight divided by this. It would give me a 0 and multiply that times 1.0. So in this particular case, the best way to do that would be to get this guy right here. Let's take this guy, surround him with parentheses, and then multiply him times 1.0. So just one side of it, and this would be the easiest side. So it says take the weight and multiply the weight times 1.0 before you do the math. Okay, and let's see if that's going to work for us. Perfect. Perfect. So the point behind this, folks, is to understand that we can come back in here and embed. This is embedding a select statement inside of another select statement, and it's extremely valuable. This is something that you're not going to find in most books, but you're going to find that it's very crucial for us to be able to do this as a programmer. I have seen programmers before, though, that will actually pass this data in separately from their program and then do the math on their side, which is much more difficult. This is by far the easier way to get it done. And these slides just simply go through those different examples that I just did with you, showing you the step-by-step process of how we might want to go back through and replace the particular column. Remember to always put your parentheses in. So find the number that you have in your statement that you've used to derive in a previous aggregate function, if you will. Plug that number in, make sure it works with the number, just like you see here. When it's done, then take that number, remove it, replace it with parentheses, and take the select statement that generated that number and put it inside those parentheses. So we've gone through this. There's a lot more that we're going to cover on aggregate functions right now. Just remember at this point that aggregate functions returns one line of information back, and that one line of information that the aggregate function returns back can be a combination of any of those aggregate functions, minimums, maximums, averages, but nonetheless, it's still a simple aggregate function is going to return one line back.